Let's name a molecule. When we first see a molecule like this, it looks very complicated and difficult to name. Luckily, there exists the International Union of Pure and Applied Chemistry, who publish recommendations and preferred names for tackling a task such as this. Because this molecule is a hydrocarbon without any rings, we will start by identifying the longest chain, which is this line of 8 carbon atoms right through the middle of the molecule. The chain has a double bond in it, so we need to include a locant in our name. If we count from the left, the double bond would be on the 5th bond. But counting from the right, it is on the 3rd bond. IUPAC prefers low numbers, so we will go with oct3ene as the name for this parent compound. Since we are numbering from the right, let's work from right to left. The first side chain we find is on the 3rd carbon and is an ethyl group, so let's note that down, 3-ethyl. Next on carbon number 4 is a propane side chain attached by its 2nd carbon, so we'll call it 4-propan-2-ol. Position number 5 has a group that looks a bit like a chicken's foot. However, the IUPAC preferred name is the much less exciting tert-butyl. So we'll make a note of 5-tert-butyl. And finally on carbon number 6, we reach our final side group, a methylidene group. Now that we have identified all of our side groups, all that is left is to arrange them in alphabetical order, ignoring specific prefixes such as tert, and stick our parent compound on the end. Doing so gives us our final name of 5-tert-butyl, 3-ethyl, 6-methylidene, 4-propan-2-ol, oct3ene. Simple. Finally, I do want to acknowledge that there is a chiral center to this molecule, and if we knew the arrangement of the substituents around this carbon atom, we would have to label the molecule as having either R or S stereochemistry.